Okay, back to number 5 of our 2025 AP Calculus AB free response questions. What we have here is a function of particle velocity. Now, these are the problems where you're going to have a particle or an object moving right and left, or you can say to the positive and to the negative directions. Pretty straightforward, but here you have to be careful. There are two particles, h and j, moving along the x-axis. For the time frame of 0 to 5, particle of h is moving at, or the position of that. Okay, so remember, I like to think of it as we have our function, our derivative, and our second derivative. For particle h, they gave you the position. Okay, so be careful there. E to the t squared minus 4t. On the other hand, they gave you j, the other particle, and this particle they happen to have given to you the velocity of this particle. So we have the second box, the derivative, Vj of t is 2t t squared minus 1 to the third power. Okay. A, find the velocity of particle h at time is equal to 1. So they're looking for this. They're looking for the derivative here. All right. Now this one can be a little bit intimidating, but it's really not that bad. It's just a basic chain rule. Okay. So we're just going to take this e to the t squared minus 4t. That's going to also drop down in the front of it, 2t minus 4. Particle at time is equal to 1, so we're just going to go in here. We're going to go 2 times 1 minus 4. That is a negative 2 in the front. E to the 1 squared minus 4 times 1. That's going to be 1 minus 4, so negative 3. So e to the negative 3. All right. So as we can see here, the derivative, all right, I would prefer that we're a little bit more explicit about this. So here I would have to write x of h prime of t is equal to, okay? And which is also your v h of t. All right, so that's what I have there. Equation is correct as well. Plug it in and we solve, and that is our answer. Another thing just to be careful with is making sure we're very explicit with it. So here I would like to see x of h prime of 1 is equal to this function, and then we plug it in to find our answer. Okay, back to our problem. During what open intervals of time t for 0 to 5 are particles h and j moving in opposite directions? Give a reason for your answer. Okay, so what is helpful in this situation is understanding that in these velocity equations, we do want to solve for where they happen to be equal to 0. Okay, so we're going to solve and add and find out where these happen to equal 0. So in this situation, we can see 0, and we can see if we take this and we split it up, t plus 1, uh, sorry, yeah, 1 is the other value that we would have in here. Same with negative 1, but we are only in from 0 to 5, right? So 0 and 1 are the turnaround points you can consider. And we can go ahead and plug in values in this situation. Plug in a number in between 0 and 1. We could just say half. So that leaves us with a 1. Half gives you a fraction. Fraction minus 1 becomes negative to the third power. So 0 to 1, this is negative. And then we can plug in a number greater than that. So let's say 2. That gives us a positive value. All right. We'll do the same test for this equation here. We want it to equal to 0. We're going to plug it into this first equation, 2t minus 4 equaling 0, 4. So that's going to give us a 2, t equals 2. So we're going to test out from 0 to 2 to 5, okay? And we're going to see where we have positive and when we have negative values. A quick thought here as well is you can say negative 4, positive 2, right? That's where we have our 2. So it's negative here and it's positive here. If you drew that right next to it, 0, 2, 5, we have negative and positive. So this section right here, it's negative for H and it's positive for J. Okay. Now we have to make sure that we explain all of that. It's going to be a lot more in terms of the reasoning for our answer. We have to be able to explain it in words here. Okay. So the derivative, which is also the velocity of H, this one on the left, right, uh, is equal to 0 at 2. And then we also have the velocity of j of t equals 0 at 1. Okay, 0 comma 1. As a result, this drawing could be enough, but you have to make sure that you label them properly. We can also say um, between, let's see, v of 0 is v of 0 to v of 1 is negative, and then v of 1 to v of 5 is positive for h. And then for j, for j, it is, oh, I flipped that, sorry. Top one was v, so that's j. For h, which is the left one, velocity of 0 to velocity of 2 is negative, and velocity of 2 to velocity of 5 is positive. Okay, so therefore, we've got to be careful with this. Velocity of h um, between at is h is negative at 1 to 2, and velocity of j is positive at 1 to 2. Okay, so that is the open interval from 1 to 2. Keep that open. Is the answer. That one took a little bit. Okay, so let's scroll down here. This one's this is a lot of notation, but again, we found it equaling to 0. Found it equaling to 0. Time is equal to 2 on the left for h. Okay. And so negative 4 to 2, positive 4 2 to 5, and then 0 to let's scroll down. And the same thing for the other equation. Take our set equal to 0, t is equal to 1. Moving left in between that, moving right. So we have equations shown, and then the particles there. I will say this one, you have to be very careful in making sure that you're clear as to your explanation there. Okay. What I always prefer is that you guys go and you box your answers. That way it's very easy to tell what your answers are. All right, it can be shown that the velocity at 2 for particle j, or the derivative of velocity. So this is going to be our second derivative is greater than 0. So we have a positive for our derivative here, right? So that means that the speed is increasing, or speed is uh increasing to the positive side, if that makes sense. Now, is the speed of particle j increasing, decreasing, or neither? If this was 0, it would be neither. Okay. However, it could be decreasing if particle j is already moving to the left. We need to make sure, is it moving to the right or to the left? So we have to plug in a 2 into this function. A 2 would give us a positive value, right? We can also tell from this part of the equation. So the velocity at 2 is positive, and then the derivative of that is also positive, so it is increasing. All right, that one's pretty straightforward. Positive, positive, same sign, speed is increasing. I know this one's getting messy. Let's get to that last problem. Particle J is at position 7 at time equals 0. Find the position of particle J at time equals 2. Show the work that leads to your answer. All right, we don't need the rest of this. Let's go ahead and write this one out. Okay, so particle J, so we're going to use our particle, this is the velocity, is at 7. Okay, so that's our starting position. Okay, our x at 0 for particle J. We're going to go ahead and add from 0 to 2 area under the curve of our velocity function dt. So that gives us, right, this is going to be of 2. Position is 7. We're going to go ahead and add the integral from 0 to 2 of this function. Okay, so we got to integrate this. Luckily, with this integration, this pops. This is already a part of that chain rule that pops out of this function, right? But we would also say we have a 1/4 t squared minus 1 to the 4th power. That pops down, gives us that. We're going to evaluate this from 2 and 0, and that is going to be our equation and our answer. Now, that's just a pretty basic and simple function to evaluate here. Okay. We plug in the 2, that gives us a 4. 4 minus 1 is 3, so we have 3 to the 4th power. 1/4 of that. We subtract, plug in a 0 is a negative 1 to the 4th power. 1/4 of that. So we just do 1/4 of. This gives me 81. 81 minus a 1, so that's 80. Okay. And 7 plus that. Divide that by 4, that's a 20. So our final answer should be 27. All right. Equation is equal to our integral, set up our integral, solve for that integral, evaluate to 2, final answer shown. Okay. That is how you do problem number 5 of the FRQ for 2025. Obviously, if I don't have to go back and check my answers and explain things as we go, your mind should be able to jump into a what exactly you need and go into that problem. This was a problem that took less than 15 minutes. I will see you in the next video for problem number 6, and that will wrap up our 2025 FRQs. See you there.